This is OpenStax chapter 10, number 30. The first part of the problem just wants us to convert our angular velocity of 2 times 10 to the 3 revolutions per minute into radians per second. So we're just converting. It's a straight up unit conversion. So first I'm going to write my angular velocity in the units they've given me, which is revolutions per minute. And I like to write it with the units very clearly labeled with the revolutions on the top and then the minutes on the bottom. And then I can think, okay, I need to get rid of the revolutions on the top and I want to replace it with radians. So I think, how are radians and revolutions related to each other? Well, 1 revolution is the same as 2 pi radians. So I'll put the 2 pi radians on the top and the 1 revolution on the bottom. That lets me cancel the units of revolutions. And then I have minutes here on the bottom. I want to replace that with seconds. So I first think, how are seconds and minutes related? I know that 1 minute is the same as 60 seconds. And I'm going to put the 1 minute on the top over here and the 60 seconds on the bottom. That way the minutes cancel and I'm left with units of seconds. So the math that I'm going to do is 2000 times 2 pi divided by 60, and I get 209 radians per second. Part B is asking, through what angle does it turn in 10 seconds? So I want to be careful here. We do have a simple equation that works only when we have constant rotational rate, and that is that omega equals delta theta over delta t. I'm not even going to write it down because I don't want you to use that when you're not allowed to use it. So you're not allowed to use that if it's not constant. But the equation that you're always allowed to do is kind of our standard kinematics problem-solving technique, which is to kind of think about what variable do you want. They're talking about what angle does it turn through. That's like asking about our angular displacement. We know our angular velocity. We know that we're going to be rotating for 10 seconds. And then the piece I'm adding here is that our angular acceleration is 0. I like to use our kinematic equations that have 4 variables always, because these will always work. So that's why I'm using this one. And I choose the kinematic equation that involves these 4 variables. Here it is. I plug in the values that we know, and then I solve for delta theta. Because my units for angular velocity are radians per second, the value we get here is measured in radians. So the angle that we move through is 2090 radians. I am rounding to 3 sig figs here. And then if we need to convert to degrees, I just need to think, well, how are radians related to degrees? And I know that in a full circle there's 2 pi radians, and there's also 360 degrees. So that's going to be my factor that I use to convert. So I'm going to say, I want to convert radians. I know that there's the relationship between degrees and radians looks like this, and I'm going to put the 2 pi radians on the bottom. That way it'll get my radians to cancel and I'll be left with units of degrees. And then I just do 2090 times 360 divided by 2 pi, and here's the answer in degrees rounded to 3 sig figs.